Alright, so now we're going to simplify rational expressions. Okay, so this is just telling you that if P and Q, so they're just talking about random expressions, and they're saying that they're polynomials, and Q cannot be 0, we call P over Q, or P divided by Q, a rational expression. Just a vocabulary term. Alright, so here, a number is an excluded value of a rational expression if substituting the number into the expression leads to a division by 0. What you really need to remember here is that if you get 0 in the denominator, then this leads to something that is undefined. Therefore, it is an excluded value. And you only care about the denominator. You only care if that denominator is 0. Alright, so let's take a look at this. So remember what I said, we only care about the denominator whenever we're talking about excluded values. So I'm going to take this denominator and I'm going to set it equal to 0, and I'm going to solve. And then that will give me my value that is excluded. So I've got 4x is equal to 7. I'm going to divide by 4. So x cannot equal 7/4. That is our excluded value. Alright, on number 2, I've got only the denominator is what I care about. So I've got 2x squared minus 5x minus 3, and I don't want it to equal 0. So I need to factor this first. So I could come up with two possible solutions that x cannot be. So I'm going to multiply 2 times negative 3, and I get negative 6 off to the side. And factors of negative 6 that add up to be negative 5 are, let's see here, negative 6 and positive 1. So I'm going to rewrite my middle term using negative 6 and positive 1. So I've got 2x squared minus 6x plus x minus 3 equals 0. Now I'm going to factor this by grouping. So I've got 2x is what I can pull out of those guys. So I've got x minus 3 in here. These guys don't have anything in common, so I can pull out a 1 though. Okay, so now we're almost finished factoring. Alright, so now I'm going to set them equal to 0 and find my excluded values. So x cannot be 3, and let's try this one. And x cannot be negative 1/2. So these two right here are my excluded values. Okay, something that people always ask about is, what if you have x over 5? What's an excluded value? Well, guess what? There are no excluded values. X can be anything, because in this case x is only in the numerator. So on this one, there are no excluded values. Alright, so what if you had it the other way around? What if you had 5 over x? Now, x cannot be, we're going to say x cannot be 0. Because remember now, x is in the denominator. We don't want 0 in our denominator, so therefore our excluded value right there is 0. Alright, so to simplify a rational expression, you want to factor the numerator and the denominator, and then you want to mark out your factors that equal 1. As long as you have the same thing on top and the same thing on bottom, then those things can equal 1. So let's take a look at that. Alright, so we have an expression here, 2x plus 7 over 5x. that is already completely reduced. You can't do anything else to it. We cannot reduce those x's because the 2x and the 7, that plus sign, it marries those things together. And so you can't split that up. So this one is fully simplified right here. Let's take a look at some that aren't. All right, number 1 right here is a lot like what we did back in Unit 2. So we are allowed to divide out the factors that they have that are the same. So 20, I can write that as 4 times 5. 12, I can write that as 4 times 3. Notice these 4's are factors. Factor is a word for it multiplies. All right, so that created 1. So I'm left with 5 over 3, but check out your x's. We can reduce those as well. Where do we have more x's at? We have more on the bottom, and you subtract. According to our rules that we learned, you subtract your exponents, and so we are left with 5 over 3x squared. All right, so look at number 2. If you factor the numerator, you get, if you factor the denominator, you get, and you can mark out exact factors. So the t plus 3's are the exact same, and what we're left with is 5 over t plus 2. So now that's simplified. All right, so take a look at this. Remember how I told you that we don't want our denominator to ever equal 0? So look at our excluded value here. Our excluded value, if you take x minus 4, set it equal to 0, and solve, you get that our excluded value is 4. Look at this on this graph. 1, 2, 3, 4. It's where this red line is, right there. So see what it does to the graph? Those graphs, it actually splits it up. So you've got the right side and you've got the left side. And so that excluded value messes with the graph so much. That's why we say that it is an excluded value. It creates what we call an asymptote there. And that is spelled like this. All right, so we're going to use a rational model to make some estimates here. The number of people between ages of 16 and 24 years who graduated from high school and the number of those who then enrolled in college within 12 months are shown in the next table on the next slide for various years. So let's take a look at that. All right, so here's our table. So take a second just to read through this, and then we're going to talk about what this means. Alright, so it says here, let P be the percentage of high school graduates who enrolled in college at T years since 1990 and within 12 months of receiving their high school diploma. A reasonable, rational model is, now notice, they came up with this for us. We didn't do this on our own, they came up with this. So, now on the next page, they're wanting us to use that model to estimate the percentage of recent high school graduates who enrolled in college in 2009. Now, P is our percentage, T is our time since 1990. And if you'll see here, we're looking at 2009. So that would be 19 years since 1990. So I'm going to put 19 in for T. Oops, instead of that, I want to put 19 in there. Alright, so now I'm going to grab my calculator and do some math. I'm going to do 3.2 times 19 plus 143, and I get 203.8. And on the denominator, I get 2.914. And so then whenever I divide those, look what I get. 203.8 divided by 2.914, I get 69.938 or so. And so I rounded, so I used the little squiggly equal sign. So that's around 69%. Okay, so then let's take a look at the next question. So the next question says, find the actual percentage of recent high school graduates who enrolled in college in 2009. So let's go back and look at our table. So 2009, this is what we're looking at. So to find the actual, I would take 2.06 and I would divide it by 2.94. So 2.06 divided by 2.94 is, you get, I'm going to use the squiggly again, 0.70068, which is about 70%. Because remember, you have to move your decimal to the right two places. So 70%. So question 3 says, is your result in problem 1 an underestimate or an overestimate? Well, in problem 1, we got 69.938%, and on problem 2, we got 70%. So I would say that we would have an underestimate. Okay, now they're asking us about 2017. So we're going to take and we're going to let t equal 27. Okay, so 3.2 times 27 plus 143 is 229.4. And I get 3.122. And so 229.4 divided by 3.122 is about 73.5%. All right, so that's it for this lesson. If you have any questions, let me know.